Let's start today to talk about the two types of probability, theoretical and experimental. When all possible outcomes are equally likely, you can find the theoretical probability of an event using the following formula. That's the theoretical probability will be the number of the favorable outcomes over the number of the possible outcomes. So theoretical, it is when all the possible outcomes are equally likely. Like if you have 3 red and 2 blue and 1 yellow, they are equally likely to happen. You didn't try them in each 5 minutes as an example to see how many balls you have. So in this way, you have theoretical probability. You have to use it in order to, the formula will be the number of the outcome, the number of the, what did you get the outcome, over the number of the all possible outcomes. The experimental probability is based on data collected from repeated trial. Experimental, that's mean I make an experiment, I make an activity in order to count, as an example, how many coins did I have. So the experimental probability will be the number of times that the event occurs over the number of times that the experiment is done. The number of times that the event happens over the number of times that the experiment is done. This is here the theoretical and the experimental probability. So the experimental, it comes from I make trials in order to count or in order to collect the data. And theoretical, like you are talking about something or an outcome that are equally likely. What's the meaning of experimental probability? Experimental probability, and like if you have a dice, okay, you want, oh, the number cube, you can say, you want now to throw it. Now to throw it here, you have to say that when I throw it the first time, now I throw it 6 times. The first time I get number 3, the second time I get number 2, the third time number 6, then I get number 1, then I get number 1, then I get number 4. So if I throwing the die 6 times, it's one of the way I get 3, then 2, then 6. So this is the meaning of experimental probability. Theoretical, that means I just say what are the what are the outcomes that can have from the throwing a dice. They are theoretical, and I will not throw the die and see how many number Q or what are the numbers will be. I just throw out all the numbers that on the number Q. So theoretical, that means that I do it in my mind, and I say that all the outcomes is from 1 to 6. Experimental, no, that I bring the die and throw it and see what are the outcomes will be. All of these are equally likely, but this one are not equally likely. They are depend on the experiments that I made. Let's have now more examples in order to understand the theoretical and the experiment. Finding a theoretical probability. We know that our solar system have 8 planets. In order to put them from least to greatest distance from the sun, as you see here, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These are the 8 planets are farther away from the sun. the lowest, or the least distance is the Mercury, and the last or the greatest distance will be Neptune. This is now a theoretical, because you don't have the planet and they bring them, they order them. No, this is theoretical. Is it right? It's not experimental. This is a theoretical one. Now, you want now, or you will randomly draw one of the names of the planet and write report on the planet. What is the theoretical probability that you will select a planet whose distance from the sun is less than the Earth? Now here you are looking about the planets and you want to see what are, or you want to find the theoretical probability of a planet that his distance less than the Earth. So what you have to do here, you have to say that the probability will be, what are the planets that they are less than the Earth, or his distance, or their distance less than the Earth? This is the Earth. What are the two planets that his distance less than the Earth? Mercury and Venus. So how many planets
Yes.
that they are less than the Earth?
Two.
Two. So my possible outcome here is 2.
2/8.
Now how many whole exactly over 8 planets? So after you simplify them, you will find that the probability here is 1/4. So to get one of the planets that they are, or their distance is less than the Earth, they are 1/4. Their distance is less than the Earth, they are 1/4. Now, here, what is the theoretical probability that you will select a planet whose distance from the sun is greater than the Earth now? Now, you want greater than the Earth. How many planets that they are greater than the Earth? Or their
5.
distance greater than the Earth?
5.
1, 2, 3, 4, and 5. Over the whole planet. How many planets we have in all?
8.
So the probability here of getting a planet that their distance is greater than Earth, they are 5. Now be careful, greater than Earth. So as you see now, I will not count the Earth. Greater than the Earth, I mean that I have to look at all the planets after the Earth. So if I tell you now greater than 5, yeah, I mean 6, 7, 8, and 9. Don't count number 5. But if I tell you greater than or equal 5, you have to count number 5.
Again, teacher, the last thing you
Yes.
said.
That's if I tell you, like, as an example, you have these numbers. Okay? And I ask you now, what is the probability of choosing a number that is greater than 5? And probability of choosing a number that's greater or less than 5. So probability of choosing a number that is greater than 5. How many number that's greater than 5?
1.
One number, which is number 6. So 1 over how many outcomes we have? We have 6 outcomes.
6.
Greater than or equal 5. How many numbers that they are greater than or equal 5?
5.
5 and 6. So we have 2 numbers over 6. I mean, like, if you have greater than 5, don't count number 5. But if I say greater than or equal 5, count number 5. Is it clear?
Yes, Miss.
Okay.
But teacher, I have a question. Why we choose 5 numbers? Why we put 5 over 8?
Here,
I mean for the
okay. Now here, look at the planets now here. Okay. How many planets that they are their distance greater than the Earth?
5.
5. Okay. They are Jupiter, Saturn, Uranus, Neptune, and Mars. They are 5. Now over. And I tell you that the probability is the number of the possible outcome over the number of the all possible outcome. Now, what are the all numbers of the planet?
They are 8.
8.
They are 8.
So you have to say 5 over 8. Is it clear?
Yes, teacher. Yes, but teacher, what's the final answer? 5 over 8?
Yes, the 5 over 8.
Okay.
Now, let's talk about the complement of an event. Complement of an event consists all the outcome in the sample space that are not in the event. Like, as an example now, let's go back now to the example of yesterday. Let's have 7 girls from the class. Farah, Jude, Huda, Jana, Judy, 1, 2, 3, 4, 5, Asma, and Asma. I choose now 7 girls from the class. Now, what is the probability of choosing a girl that her name starts with letter J? Oh, okay. So now, what are the girls that their names start with letter J?
Jude, Jana, or Judy?
Exactly.
Yes.
So 3 letters. So 3 girls. So the events here are Jude, Jana, and Judy. This is the 3 girls. Now I took them out of the class. When I took them now, what are the girls that they are left? We have Farah,
Huda, and Basma and Basmala.
Huda, Basma, and Basma. So my event now is choosing these 3 girls because that their names start with letter J. Now, Farah, Huda, Basma, and Basmala are girls in my outcome, in my sample space, in my class. But it's not in my chosen. So Farah, Huda, Basma, and Basmala, I call them complement of the event. That's if I add them to my girls that I choose them, I have the sample space. I make the class. So the girl that I choose is my event, and the other girls such as Farah, Huda, Basma, and Basmala that I didn't choose them, I call them the complement of the event. Is it clear now what's the meaning of the complement of the event?
Yes.
Yes, Miss.
Okay.
Yes. Yes.
Now,
Teacher, the event. Teacher, what was the event?
the event that is the, I told you, choose girl, start with letter J. This word is the event.
Ah, okay.
Now, let's come back. So, now I need to find now the probability of choosing girls that they are start with letter J. So how many girls that they are start with letter J? We said 3. Over how many girls in the class?
8.
1, 2, 3, 4, 5, 6,
7. No.
7. So the probability of getting a girl start with letter J, 3/7. Now, what is the probability of the complement event? Complement events, that mean girls that their names didn't start with letter J.
4/7.
4 over.
Bravo, 4/7.
4/7.
So 3 girls start with J, and 4 girls start with, didn't start with J. Now, here now, I want you to know that the probability of the event of choosing J and the probability of not choosing J, if you add them, what did you get? 4/7 plus 3/7. What did you get?
7/7, which is
7/7, which is
1.
1.
So the probability of an event plus the probability of not event is 1. In other words, that's the probability of without counting them. I mean, like here, I don't know the numbers. And I have now, I know that the number of the girls start with letter J is 3/7. Okay, the number of the girls start with J is 3/7. So if I tell you now how many number, or what is the probability of not to start with J, what did you say?
4/7.
Yeah, but how did you know that's 4/7? You subtract the events of J from 1. So, because you know then they are 1. So 1 minus the probability of, with 1 minus our probability of J, when you subtract them as 7/7, you get the probability of not J. So the summation of an event and its complement is 1. Let's have now more examples in order to understand. Finding the probability of the complement of an event. In a test, 5 participants are randomly given a beverage to sample. There are 20 samples of drink A, 10 samples of drink B, and 10 samples of drink C, and 10 samples of drink D, sorry. So here we have 50 participants. Now, for this 50, 20 samples for drink A and 10 samples for drink B, 10 samples for drink C, and 10 samples for drink D. This is now the data I have. Now, what is the probability of a participant not getting drink A? Not getting drink A.
30.
Now, let's see here. Be careful. Probability, you don't say 30, it's 30 over something.
Yes. Yes.
Yeah. Now, so here we need to find now the probability of not getting A. How would you solve it? The first way, you have to find the probability of getting drink A.
20 over 50.
Which is 20 over the whole number, which is 50. And then I don't want getting A. I want the probability of not getting A. So the probability of not getting A will be 1 minus 20
over
50. And then in order to subtract, I wrote them as 1 over 1. Since the denominator here is 50, so I will write it here as 50, and up I will write it as 50 in order to subtract.
30 over 50.
Then you have the same denominators, and then 50 minus 20 is 30. So you will say that the probability of not getting A is 30 over 50, or you can simplify it as 3 over 5. So a way to solve not getting drink A, you can solve it by this way. You find the probability of getting A, then you subtract the probability of getting A from 1 in order to find the not getting A. Or there's another way, that's not getting A, that means B, C, and D. Yeah, I mean like, so not getting A, that means I take B, C, and D. That they are 10 plus 10 plus 10 over 50, which is 30 over 50. So 2 ways. You can find the probability of who getting A, then subtract it from 1, or you can say they're not getting A, I mean like getting B or C or D. I add the probability of B, C, and D over 50. Is it clear?
Yes, teacher.
Yes, teacher.
Now let's go to solve this problem here. This is from number 10 to number 21 in your book, page 773. Now, number 1, 3, and 5 are blue, 6, 2 are red, and number 4 is green. Now, the spinner at the right is divided into 6 equal parts. Find the theoretical probability of landing on the given sections of the spinner. Yeah. Let's start now with number 10. Probability of blue. I want now to find the probability of blue. Probability of blue. So what is that my event now? My event is getting a blue.
3/6.
How many blue here?
3.
Over.
3.
How many parts?
6.
6. So which is 1/2. Number 11. What is the probability of getting white now?
0/6.
Bravo. 0/6. There's no white, which we say that it is impossible to happen. Number 12. What is the probability of choosing number 5? How many 5 here?
1/6.
Bravo. 1. Only we have 1 5. 1/6. Now, number 13. Probability of the numbers that they are not less than 3. When I say word, when I see word not, what do you have to do? First, you have to solve it by not less than 3. I mean, first, you have to find the probability of less than 3. Then subtract 1 from it. So let's first here. So the probability of not less than 3. This is a complement. So first you have to find the probability of less than 3. Then you have to subtract 1 minus the probability of less than 3 in order to find the probability of not less than 3. So the probability of not less than 3 will be 1 minus the probability of less than 3. Is it right?
Yes,
Yes,
miss.
teacher.
Not less than 3, يعني 1 minus probability of less than 3. Now, what is the probability of choosing a number less than 3?
2/6.
2/6.
Bravo. How many? Now, first ask yourself, how many numbers that they are less than 3?
2.
2 and 1. So 2/6. So I want now not less than 3. So 1. So this is here. You can write it as, how did you solve it? This is 1/1. Since the denominator here is 6, so change 1 to be a 6. And since you multiply the denominator with 6, so you can write it now as 6/6. Then after that, 6 minus 2 is 4/1 of the denominators, so 4/6. So not less than 3 will be 4/6.
Teacher, I will not simplify to become 2/3.
Yeah, then you can simplify it now to be as 2/3. This is here for number 13. Is it clear?
Yes, miss. Clear.
Now, number 14. Probability of choosing number 8.
Impossible.
Impossible.
0/6.
Bravo. 0. Number 15. Probability of getting even.
3/6.
How many numbers are even now?
2, 4, and 6. 3 numbers.
2, 4, and 6. There are 3 numbers. Bravo. And over how many parts we have? We have 6 parts.
6.
So we can say that the probability of getting even is half. Now, number 16. The probability of not 2. Not 2, I means like it is 1 minus probability of getting 2. So not 2 means like the probability of not getting 2. And 1 minus. What is the probability of 2?
1/6.
1/6. The probability of getting 2 is 1. Oh, there's only 1 2. So I will say 1/6 parts. Then you will subtract it as I told you before. This is 6/6. So it will be 5/6. Is it clear?
Yes, teacher, it's clear.
Teacher, can you wait?
Okay.
Yes, miss, I finished.
Now, number 17. Probability of choosing less than 5. Yeah, less than 5. How many numbers that they are less than 5?
4 numbers. 4, 3,
We
2,
have
and 1.
4, 3, 2, and 1. So we have 4 numbers over 6 parts. We can simplify it now as 2/3. Now, number 18. Probability of not green. When you see word not, what do you have to do?
Minus 1 of the probability of getting green.
Bravo. Minus the probability of getting 1 minus the probability of getting green. Now, so 1 minus. What is the probability of getting green? How many 1 are green here?
1. Only 1.
Only 1.
Well, so
How many
5/6.
parts? From 6. So you have to say that then 1 will be 6/6. So it is 5/6. So the probability of not green is 5/6. Number 19 now. The probability of not red.
Not red, 6/6, miss, because there is no red.
No, teacher, it's going to be 4. 4
Oh,
over
they mean these.
4/6.
So at first not red, يعني 1 minus probability of red. So 1 minus. What is the probability or how many red we have? Probability of red means that I want to find now the probability of red. That's how many red we have now? We have 2 reds. Oh, over how many parts we have? 6 parts. So probability of red means how many parts of red? We have 2. And how many the whole parts? How many parts we have? We have 6. So then we say that it is 6/6, which is 4/6. The probability of not red. Is it clear?
Yes, miss.
Miss, why I see
Yes.
only Farah and Nada are talking. The others, Miss,
Teacher.
are they clear?
I am writing, teacher.
Teacher, I am
It's okay, but did you understand?
Yes, 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 ma'am.
Yes.
Number 20 now. And number 20 here, probability of even or odd.
The total 6/6.
6/6.
Bravo. هلا words of or it's in the probability, or it means plus. Or when you see word or, word this is or يعني it's mean plus. So will be the probability of even plus the probability of odd. Or even or odd يعني probability of even plus probability of odd. Now probability of even, how many numbers that they are even?
3.
2, 4, 6.
3.
So 3 numbers.
9.
Over how many whole numbers we have?
3/6. Over 6.
Now odd. What are the odd numbers? 1, 3, and 5.
3 also. And
So
5.
3 are numbers, all over 6. So when you add them, you get 6/6 or 1. Now the last part here, number 21. Probability of greater than 4. Yalla, quickly. How many numbers that they are greater than 4?
2/6.
2/6.
2.
2 numbers
Over
over
6.
6. 5 and 6, only 2 numbers. So 2/6.
Teacher, just a minute, teacher.
Okay. The period will finish after less than 1 minute. So you can write, and if you finish, you can